E1CB mechanism. Elimination unimolecular conjugate base mechanism. This mechanism occurs in two steps. It is a two-step mechanism. This occurs in the presence of a strong base. This mechanism is favored by strong bases, and another condition is the substrate molecule should have poor leaving group, bad leaving group. Then only this mechanism will occur. Now let us start our process with one overall reaction. Let us write the overall reaction. This is the substrate molecule and this is the strong base. In this substrate molecule we are having fluorine. Fluorine is a leaving group. It is a poor leaving group. This carbon is alpha carbon and this carbon is beta carbon. And here on this beta carbon there is one hydrogen. It is called beta hydrogen. Here this base will abstract the beta hydrogen and we will get BH. Fluorine will go out in the form of F minus, fluoride ion, and the resultant is C double bond C is formed. That implies we are getting an alkene. This is the overall reaction which we are going to consider. Here a single bond is converted into double bond. One hydrogen and one fluorine are eliminated. Therefore it is a elimination reaction. Here we have to use the high temperature condition. This reaction occurs at elevated temperature. Now let us learn the mechanism. As I said, the mechanism is of two steps. The first step is deprotonation of substrate molecule. Deprotonation means removal of proton. Here we have to consider the substrate C single bond C. One fluorine is there and one beta hydrogen is also there. In the first step, the strong base will come and attack. We know that the strong base will immediately respond to the hydrogen. It will send its lone pair to the hydrogen and it will remove the hydrogen in the form of H plus. Therefore we will get BH. Because hydrogen is removed, this carbon will get negative charge. Therefore C single bond C, fluorine is there and this carbon is going to get negative charge because hydrogen is removed in the form of H plus. Deprotonation has taken place and here we got this molecule, ion. In this ion there is negative charge on the carbon. Therefore we will call it as carbanion. When we compare this carbanion with this parent molecule, it is having one hydrogen less. Therefore we have to call this ion as a conjugate base. It is the conjugate base of the original substrate molecule. This process is a reversible process and it will occur fast. Therefore very quickly we will get this carbanion. This is the first step. Second step is the cleavage of carbon fluorine bond. In this carbanion, the fluorine will go out in the form of fluoride ion. That implies slowly this bond breaks. The two electrons come on to the fluorine and the fluorine will come out as a F minus. This occurs very slowly because there is a cleavage of CF bond. As I already said, fluorine is a bad leaving group. It requires more time for the breakage of this bond. So anyway fluorine is coming out in the form of F minus. Now this carbon will get positive charge and therefore this negative charge, these two electrons will come here. Then we will get C double bond C, two bonds and two bonds. That implies we will get an alkene. Therefore We have explained the overall reaction with the help of two steps. Therefore, it is a two-step mechanism. And in this, the intermediate formed is carboanion. It is a conjugate base of this one. Therefore, we will call it as even conjugate base mechanism. Now, let us discuss some important points. Number of steps is equal to 2 steps. Favored by dash bases, weak bases or strong bases? The answer is strong bases. Strong bases like OH minus, OCH3 minus, NH2 minus, so on. Substrate molecule should contain dash leaving group. Good leaving group or bad leaving group? The answer is bad leaving group. Examples of bad leaving group in our syllabus are fluorine group and OH group. Intermediate formed is carboanion or carbanion. Carbanion. And now the fifth point is about rate equation. Rate of reaction depends on the rate determining step. Here this slow step is the rate determining step, and here on the reactant side there is conjugate base. Therefore, rate of reaction is directly proportional to the concentration of conjugate base. Because here we are having power 1, therefore this reaction becomes first order reaction. Because one molecule is influencing the rate of reaction, molecularity of this reaction is equal to 1. Carbanion intermediate is stabilized by dash groups. Here we are having carbanion intermediate. It is stabilized by dash type of groups, electron withdrawing groups or electron releasing groups. The answer is electron withdrawing groups. Electron withdrawing groups. Why? Because when there is an electron withdrawing group here, it will reduce the negative charge on this carbon. Then automatically this intermediate formed will become more stable. The intermediate formed will become more stable when there is electron withdrawing group. Therefore, electron withdrawing group will stabilize the carbanion intermediate formed. So these are the important points in even CB mechanism. Now let us compare the even mechanism, E2 mechanism and even CB mechanism simultaneously. Comparison of even E2, even CB mechanisms. Number of steps. Even mechanism occurs through 2 steps. E2 mechanism 1 step. Even CB again 2 steps. Favored by dash bases. Even mechanism is favored by weak bases because it has to occur through 2 steps. Weak base will wait for the second step. Therefore, it will go through 2-step process in case of weak base. And coming to E2 and even CB, these 2 mechanisms are favored by strong bases. Strong base and again strong base. Order of reaction, here it is 1, here it is 2 and again here it is 1. Next, molecularity 1, 2, 1. Intermediate formed. In even CB mechanism, carbocation intermediate is formed. In even mechanism, carbocation intermediate is formed. In E2 mechanism, only transition state will be formed, no intermediate. Coming to even CB, carbanion intermediate is formed. Next, effect of leaving groups. These are assisted by good leaving groups. This is also assisted by good leaving groups. Coming to even CB, it occurs only when there is poor leaving group or bad leaving group. Stereochemistry. In even CB even mechanism, there is no need of any stereochemical condition, but in E2 mechanism, the beta hydrogen and leaving group should be anti-periplanar to each other. Then only that the E2 mechanism will occur. They should be anti-periplanar to each other. And in even CB mechanism, there is no condition. So we have the condition only for E2 mechanism. Beta hydrogen and leaving group should be anti-periplanar to each other. Last point, rearrangements. Because carbocation intermediate is formed, there is a possibility of rearrangements. Because carbocation intermediate is formed, there is a chance of rearrangements to occur. Here there is no chance of rearrangements, and here also there is no chance of rearrangements. So these are the main differences between even E2 and even CB mechanisms. The main point here is, when we are having a poor leaving group and a strong base, then the process will occur through even CB mechanism. When we are having a good leaving group and a weak base, it will occur through even mechanism. When we are having a good leaving group and a strong base, it will occur through E2 mechanism. So all the thing is concentrated at these 2 points only, base and leaving group. Base and leaving group will decide the mechanism for elimination reaction. For the strong base, it may be even CB or E2. For weak base, it is even. In case of good leaving groups, it may be even and E2. In case of bad leaving group, it is even CB mechanism. So this is the comparison between even E2 and even CB mechanisms.